Hey guys, have you ever tried bringing up ACI Fabric from scratch? I bet you haven't. Even if you have, probably you didn't use automation, so you felt like a monkey. Clicking in the UI, try to find the specific place where you need to add the policy that you want. So you finally found that place, you added a policy, you close the window, and as soon as you press this close button, believe me, you will never be able to find your way back to this window again. Sounds painful, right? So we know how to make it less painful. And the keyword here is automation. So this video will kick off a course where I will be showing you how to start automating ACI with Terraform. Why Terraform? Because I like it, and also because Cisco invests now a lot of effort in developing ACI provider. So our goal for this specific episode is going to be start looking at this provider. So how to declare this provider, how to configure this provider so that it can reach ACI. And also we'll use Terraform to build and ship our first very simple configuration to ACI. Don't want to keep this introduction too long, so let's get started. So we start with an empty working directory. There is no files. What we need is to create a main TF. That's going to be our main Terraform configuration file. Because we want to use ACI provider for Terraform, we need to, first thing we need to do is to announce or to declare this provider. And for this, Terraform has a specific format, which is Terraform. Then you need to specify required providers, and then the name of a provider, ACI. So that's going to be a local name, so it's only locally relevant, but I suggest you stick to the provider naming that is official. So in this provider definition, we can specify two things. One is a source, which is basically because Terraform has many providers, so it needs to know where to look for your specific provider. So we say Cisco DevNet and then provider ACI. This is the source. You can also specify the version, and this is handy when you want some specific version to use, but if you just want the latest one, which you usually want, then you can just skip that and Terraform will go and get you the latest one. So this is how we declare the provider. So now in order to let Terraform get this provider, we need to initialize working directory. So we do Terraform init. And as you can see, Terraform went and installed the latest version of Cisco ACI provider for us. And we're looking for this green line, which is Terraform has been successfully initialized. So if we go back, this is how we declare the provider. So let's say provider declaration. What we also need to do to start using this provider, we need to configure. So provider. And when I say configure, what I mean, provider needs to know how to reach ACI. What is the URL? What is the username? What is the password? So we say provider ACI, and then we configure this provider. User, no, let's start with the URL. So the URL is https://nut.cisco.com, and then because I'm using nut, it's gonna be port 2.129.1. So behind this URL, I have an ACI simulator that I use just for this demo. Then we need to specify username, which is Terraform user. So this user has been created on the ACI simulator already. And we also use password Terraform 123 exclamation mark. Very secure password. So this is provider configuration. Now provider knows, or Terraform knows, how to reach ACI. Next step would be to configure something in ACI. And when you configure something in ACI, that's an object. So if we want, for example, to create a tenant in ACI, that's going to be an object. EPG, going to be an object. Bridge domain, going to be another object. For every specific object in Terraform providers, you have something that is called resource. So to create a tenant in ACI, we would need to use a resource. How do I know which resource I want to use? For this, you go to Terraform registry, you have this provider, Cisco DevNet ACI, the latest version, and then you look for tenant. And it shows you that for tenant, you have ACI tenant resource. So basically, you will find all information here. Example usage, the name, annotation, or the attributes that you need to feed into this resource so that it works. So if we go back to our code and say resource, then the name ACI tenant, this is basically the resource name that I take from here, from documentation. Then we have another name which I want to skip for now. And in this resource, we have to specify the name of our tenant. So the name's gonna be tenant vanilla, because this is the most beaten and simple example of an object created in ACI, a tenant. So I skipped this name. What is this name? This is the local name. So when do we use this? Imagine you have another resource here, which can be ACI bridge domain, for example. So bridge domain will belong to this tenant, and if you want to refer to this object from this object, you need to use this local name. So here under the bridge domain, or bridge domain actually not a very good example, but imagine the bridge domain relates to the tenant. So we say a bridge domain, here we say refer to ACI tenant dot local name. So this local name is only relevant for this specific Terraform configuration. So let's do also vanilla. Okay, so now we are ready to push our tenant to ACI. We go here and say Terraform plan. So Terraform actually keeps track on your deployment. So it knows what has been deployed, and so it's stateful, unlike Ansible, which is stateless. So Terraform here says, okay, my plan is to add one object, 0 to change, 0 to destroy, and I will go and add ACI tenant resource with the name vanilla. So this is the plan. To actually push it, we need to apply Terraform apply, and we need to confirm. Okay, success. We have one resource that was added to ACI. Let's check if indeed it is in there. So I want to log into ACI admin. And let's go to tenants. And vanilla is here. So I'm not sure if you can see, so I will zoom in. So this is tenant vanilla, and here on the left you have this blue gear. So this means that this tenant is being managed by some external orchestrator like Ansible or Terraform or whatever you want to use. But how does ACI know how does ACI know that this specific tenant is managed by external orchestrator? So let me show you. If we go back to our directory and if we do, actually let's do this. Let's see, we have a new file. After we did Terraform apply, we have a new file. This is a Terraform TF state. So you remember I told you that the Terraform keeps track on your deployment. So this is the file where it stores the state. So if we do cat Terraform TF state, we see that this file stores some objects. And there's an object ACI tenant with the name vanilla and with some attributes that we gave to it. So the name is vanilla, but also here we have an attribute annotation, which is orchestrator Terraform. So this is not something that we specifically or explicitly configured. This is something that Terraform added by itself. And if we go now here in ACI and open this tenant object, in the object store, you see that this is a tenant, the name is vanilla, and also this object has annotation, orchestrator Terraform. So this is how ACI knows that it needs to put this blue gear, and this object is externally managed. Okay, so we have pushed our configuration to a single fabric. However, we know that most of the fabric nowadays have multiple sites. And in ACI, when deployment has multiple sites, you have an additional orchestrator, which is the MSO. It's called multi-site orchestrator. So imagine you also want to go to the MSO, you want to use Terraform to go to the MSO and push your tenant there. So what do you need to do for this? For this, we want to use another provider, which is called MSO, and we need to declare it. So why is there a separate provider? Because MSO is a separate dedicated entity that you configure, so it has its own API. So it's, as I said, that this is the orchestrator for the local ACI sites. So we say source in a similar way, Cisco DevNet MSO, and this is how we do the declaration. So here let's put this was a single site, and here we start with multiple sites. In Cisco's terminology, this is multi-site. So we have declared the provider. Now we need to configure this provider. So again, similar to ACI, we use provider. This time it's MSO, and then we use URL, which is going to be https net.com, and the port is going to be 134.1, and the username is going to be Terraform user, and the password is going to be Terraform 123 exclamation mark. So we have configured the provider, so now it knows where to go and reach the MSO. Last thing we need to configure here is that actually our object that we want to push. So for this we go to documentation again. So please note that this is the different provider now, provider, Cisco DevNet MSO, and we look for tenant here, and we have a resource that is called MSO tenant. So quite similar syntax to the tenant that we use with the ACI. We go here, we say resource, MSO tenant, and the local name is going to be also vanilla, and the name of the tenant is going to be vanilla. So this name overlaps with this name, we don't really care, because if we want to refer to this object from some other object, we will mention not just the name, but the type of the object, which is going to be MSO tenant in this case and ACI tenant in this case. So they are different. That's why we can have overlapping local names for these two resources. That's it. Let's try. If we go back here and if we do Terraform plan, oops, it says could not load plugin. That's expected because we didn't initialize the MSO plugin. So let's do again Terraform init. As you can see, it went and downloaded the MSO provider, and again Terraform has been successfully initialized. So let's do now Terraform plan. Okay, an error again. So it says we are missing an argument, and which specific argument is that? Is a display name is required, but no definition was found. Okay, but we actually put a name for our provider here, vanilla. So why does it want also display name? So let me show you. If we go to MSO, and let's say we want to create a tenant, so here you see something that is called display name, and we say vanilla. But also down here you have internal name. So the display name is something that you are going to be seeing only in the MSO UI. And internal name, because MSO is the orchestrator for local ACI fabric. So the internal name is actually the name of this tenant that is going to be pushed to the sites. So why do we have two? Because here, for example, I may want to have something like this. I may want to use special characters in the naming, in the tenant naming. Internal name, as you can see, it didn't change, so it strips off the special characters. That's because ACI does not accept it. So APIC, local site, will not accept the name with the $signs because it has this limitation. It doesn't accept the special characters. So that's why we have display name and internal name. But we will not create a tenant now from here. I want to create it from the Terraform. So we need to add another attribute here, which is a display name, and it can be also vanilla. Again, let's save it and let's do Terraform plan. So as you can see, we again have one object to add. And if you remember, I told you that the Terraform keeps track on what was deployed. So it will not go to ACI and deploy this tenant again. This time it knows that the tenant in ACI has been deployed, but the tenant in MSO has not been deployed. That's why we have just one object to add. And if we do now Terraform apply, yes, success. Also in the MSO, we should have our tenant now. Yes, we have tenant vanilla. So that's it. That's it for local authentication. So as you may notice, I use the local users both in APIC and also in MSO to authenticate. However, in real life, if you, and let me show you this. Let me log out. So in most production deployments, what you have is something like TACACS or radios. So this is the remote authentication server. I can use it even now. So in order to be able to use it, I need to specify a domain. So I want to say, okay, I want to authenticate against the TACACS server. And here you can configure it differently. So you can make the TACACS option the only available. But in my case, I have default auth, which is local authentication, and TAGX. So how do we handle this with Terraform? So let's say I want to use TAGX. Then I need to actually in the background, in the backend, I have a TAGX server with a user configured there, and this is the TAGX user, and it has a TAGX. The password is TAGX123 exclamation mark. But how then I can tell ACI to use the TAGX domain, not the local one? For this, you have to do some dancing around colons and backslashes. So you do APIC colon, then you put the domain name, which is TAGX, and then 2 times backslash. 2 times backslash. So this string will tell ACI that you want to authenticate against the TAGX domain. Let's see if it works. So let's do Terraform plan. And yes, it should say that infrastructure is up to date. So let's actually destroy what we have created, because we then can quickly recreate it. Destroy, and 2 objects destroyed. If we go back to APIC, oh yeah, I should put the local authentication here. And if you now look in the audit log, you will see that the tenant vanilla was deleted and the user is remote user, TAGX user. So not the Terraform user that we used before, but a remote user. So if you want to do the same, if you want to use TAGX with MSO, you can do the following again. TAGX user, TAGX123 exclamation mark. But instead of dancing around this columns here, you do something that is more simple. You specify domain TAGX. Let's save and let's do Terraform plan and Terraform apply. You can actually skip planning and just do apply. That's no problem. Yeah, it worked. So we have added 2 resources. So that means that remote authentication also works for the MSO. So let me show you the last bit, and the last bit will be certificate-based authentication, or some call it signature-based authentication. So this is a way when you can skip having a password in here in clear text and instead using a private key. So Terraform will use a private key to sign every message that it sends to ACI, and ACI will use a public key to verify the authenticity of this private key. So this sounds cool on paper. However, you may ask, where do I get the keys? So let me show you how you can generate the keys. For this, we will use the OpenSSL. And we need to say that this is a new request, and this is actually the new key, which is going to be the RSA key with the length 1024, and then it's going to be X509 certificate, and then we need to specify nodes. So this means that the private key will not be encrypted, so the system will not ask you for the PEM, actually the password. And then we also need to specify the key out. So key out is the file where you will store your key, private key. So that should be Terraform user key. And then out, this is the file which will have a public key or the certificate. So Terraform user CRT certificate, and the subject for this certificate is going to be CA, which is or CN, which is the common name for Terraform user. Then organization equals Cisco, and then country equals NL. I hoped I typed everything correct. Yes, and if we do now ls, then we see that we have now our keys Terraform CRT, Terraform key, which is a private key. So if we do cat on Terraform user key, we can see the private key. If we do cat on Terraform user cert, we can see the certificate. So you need to take this certificate with everything, including this begin and end, and you need to go to ACI, and you need to attach this certificate to your user. So we have Terraform user, and this is the place where you attach the certificate. So this is the certificate, and we need to give it a name. It's going to be Terraform user cert. So remember this name. We'll have to use it in Terraform user cert. We'll have to use it in Terraform configuration. So let's close this one, and we are now ready to change. So we don't need password anymore, and the username should be again the local user, Terraform user. But instead of the password, what we can include here is the private key that we have just generated. So the private key will be Terraform user key. And also we need to specify, we need to let ACI know which certificate actually matches this private key. So we say cert name, and then remember I told you to memorize the name. So it's going to be Terraform user cert, like that. So that should be enough to enable the signature-based authentication. So if we do now Terraform plan, let's see. Yeah, we need to destroy. So if we do Terraform destroy, yes, success, 2 objects destroyed. And if we go now to system, again, audit log, we see that the tenant vanilla was deleted by Terraform user, which means that our signature-based authentication is working. So this is how it works. As you can see, it's not very difficult to start automating ACI with Terraform. And of course, it will get much more complex when we start pushing more objects and creating a relationship between them. But this you will see in the next video. This video is finished, and last thing I want to mention for those of you who think I want to practice but I don't know where to get ACI from. You have 2 options. Option A is to get a simulator VM from Cisco, free of charge, cost you nothing, but you should have a server where you want to put this VM, and it's quite resource hungry. Option B is to use a public simulator that Cisco put up online. That one is not only yours, it's shared, but I will put URL and credentials in the description of this video. With that, thank you for watching and see you next time.